Right. So on Monday's session, what I wanted to go through with you was a detailed understanding of secondary storage and the difference between an interpreter and a compiler. All right. Now, the first thing, before I go into the nitty gritty of that and go into a bit more detail, the first thing I want to draw your attention to is application software, because when I've gone through some mock papers, some of the things that people have made a mistake of doing is they've named specific applications. Now, remember that application software is all to do with the general using of the machine, your front end user. Right now, you are all users. If you have something like social media, you are a user. It is not your account, it belongs to the company. You use their service. And the same applies to computer systems when it comes to application software. But the name of the different pieces of software that you will use include word processors, which is for business documentation, spreadsheets for use of numbers, image editing if you need to change a photograph or add something to it. We've got video editing and web browsing. Now that's relatively straightforward. That's not what I really want to go into a lot of detail. One of the questions you had in your mocks when I was going through them gave you some true or false statements. Do you remember those about the hard drive and so on? Um, a lot of students get that wrong. Even some of my year 10s, when I've just gone over the similar question, when I've put it into their mock paper, they made mistakes on that question as well. I think you need to understand the actual technical side of how things work so you can understand it a bit better. So I want you to think about how an optical drive works. All right. Now I've got an optical drive here. All right. Now, on the surface of this CD, it's so microscopic you cannot see it, all right? But there is something called pits and lands. When that CD is spinning, there is a laser shining at it, all right? But every time that bump changes, it changes the binary digit, all right? So it will change to a 1 or a 0. So if it goes up, that's it changed to a 1 and it stays on a 1. Then if it goes down, it goes on the 0 and stays on the 0. So it's only when it's changing that the binary digit changes. You don't necessarily need to go into that much detail, but you do need to understand you've got pits and lands, okay? Now those pits and lands are how we read the data. And what you've got on there, all right, is a mirror. The laser shines through it and it reads it onto the surface. So optical discs, they use the laser beam to read the pits and lands. There is a disc that's spinning quickly, all right? The drive uses a difference between a 0 and a 1 when the pit and land changes. Now, you don't necessarily need to know it, but somebody asked me the other day, what happens with rewritable discs? Well, with those, believe it or not, the surface of that disc has a metallic material that is melted so that it's set all at 0 again. And then when the disc is, hence CD burning, it burns onto the surface, the pits and the lands. That's how CD burners work. But you need to understand the theory of that in case you get asked a question about it, all right? Now, this is the one that threw a lot of people off, how hard disks work. Now, hard disks have platters, all right? You can have multiple platters, but you can see here you've got an actuator arm. It's better for you to see things visually because the amount of people that have gone wrong in a test because they've said a HDD, all right, can be portable. No, it cannot. In fact, all right, so that should say how a HDD works, all right, magnetic. I want you to look at that now and memorize what a magnetic hard drive looks like because it's big. Could you imagine? All right. So if you're asked a question about the type of storage you would use on a portable device, is that that's close enough to the actual size? Would you strap that onto your phone? Absolutely not. 100% not, because it's heavy, it's bulky. But the thing about that, because you can visualize it, there's magnets on the surface, on the platter, and on the actuator arm, you've got your north and south pole. All right. And the magnets, when it changes the charge, that's what changes it to the 1 and the 0. But you might have one actuator arm with one platter spinning, but then you can get two platters spinning and you have two arms that read it together with magnets either side. Or you might have three with three arms or four arms. Do you see what I mean? All right. Some people didn't realize in exams in the past that you have the multiple platters spinning with the positive and negative charge, all right, with the, I say charge, with the magnets, all right, and that's what gets it working. Now, files are written sequentially on that disk and it's spinning at a super fast speed. But if I had to compare that one to solid state, which one's better? Why would you say solid state?
Because it's more portable
Okay,
and has fast access speeds.
okay, good. That was a trick question, by the way, and I'll tell you why in a minute. Yep.
HDD because it's more durable, like it would last longer. So
Okay, so hard disk magnetic HDD because it lasts longer, more durable.
More robust. It's less hard.
Which one's more robust? Which is called begins with an S. Solid state. Okay. Yes. All right. All of those points that we've just made there need to be included. And what I've done is I found this grid online, which is really useful. And you'll be able to watch this back. So you can see that CD drives, DVD drives, Blu-rays are all optical types of drive. They are slower than hard disk drives, but they are faster than magnetic tapes. Magnetic tapes, all right, they have the problem with magnetic tapes, just in case you get this, on a network when they have to use a cassette tape or magnetic tape, if they need to find a file from ages ago, they have to rewind the whole tape to find the file. So just be aware of that with backups. But solid state is good for portable devices. But the problem with solid state is that over time, the transistors inside break down, which then means it doesn't work anymore. So it's got a limited read and write lifespan. So you've really got to understand. Whereas a magnetic hard drive has a much longer lifespan. All right. How long are magnets going to last? A lot longer. But the problem is the transistors over time burn out inside a solid state drive. Solid state drives are also more expensive. So if you get an exam question where they're asking you and they happen to sneak into the little introduction something about budget, what one are you going to go for? Magnetic hard drive, because they're cheaper per gigabyte. All right. Now, just to finish off this revision session, I'm going to talk a little bit about high-level programming languages, because some of you wanted to know the difference between high-level and low-level. Now, what I've got here, I've got two slides. All right. So you can see the example here. High-level programming language is your Python, your JavaScript, those sort of languages. But if you have a look here, a low-level programming language, that is your assembly code. So you've got high level, low level, then machine code. The machine code is in its purest form. It's what computers understand, your binary, your ones and your zeros. Low level is close to it, not quite there yet. Now, just so you know, these are taken from exam specs, from exam mark schemes. So high level languages are more supported worldwide. What that means when it says it's better supported, all right, there is lots of guidance there. Think about it. When you open up PyScript in my lesson, if there's something you don't understand, you can go to the help files and it will bring it all up for you, won't it? You can find out what little bits of code do, all right? High-level programming languages also have subroutines built into them that you can use. Think about it. There's libraries there as well. It's got structures such as iteration, selection. Think about it. When you do the if this happens, I indent. It's got those structures there that help you as a developer. Code written in high-level programming language, believe it or not, is usually shorter. When I write one line of Python, believe it or not, that might be 10 lines of assembly. Because of the way assembly code runs, and I'm just going to show you the example again in a minute, to do one instruction like adding numbers together, all right, let's say multiplying, you might have to do shifts, binary shifts, and so on. All right. Whereas it's one line of code in Python. So just be aware. You can create subroutines, gives you data structures. It's easier to understand and read. And you'll see in a minute what I mean by that. And it's also easier to debug. Now let's have a look at low-level languages. All right. Now low-level languages, I wonder if I can zoom in a little bit on this slide. And let's get rid of me off there so you can see it. So a low-level language, all right, just to work out the surface here, what this is doing is it's using registers. So low-level languages tend to use, like, directly access the main memory, whereas in high-level programming languages, you don't tend to have that. You need, in low-level languages, you also need a translator to get it from assembly into machine code. All right, so low-level languages need a translator to change it from its form into machine code so that the machine can understand it. Low-level languages can be executed much faster because, think about it, you've already taken out the middleman, all right? So you can translate that much faster. But high-level programming isn't always optimal, all right? So what this is saying here on the slide, low-level languages can be executed much faster. Converting code from high level into low isn't always the most optimal, but low-level language is closer to binary. That's what it's saying. If you have a look, basically, in a nutshell, one line of code could be multiple. I've just said that a minute ago. Now, I'm just going to show you this comparison table. I would, and I can give you a copy of these slides by the end of the week, all right? I would copy these out so you have an idea inside your head, all right? Do you know what a compiler does? What does the compiler do? Yes.
Translates a high-level code, high-level language to machine code.
Yes, all right?
And it does it. It translates the whole
The whole thing.
program and then executes it.
Yeah, all right? So the compiler translates the whole program. So you know when you're in Python, all right, you can compile it. It will make a executable file, and that's straight into machine code, all right? The problem with that, all right, just so you're aware, because it might ask you disadvantages of it, all right? When I use a compiler and it makes that file, I can only use it on the same type of machine that has the same instruction set on it. So if you wrote a piece of software in here and wanted to use it with every computer in this class, it's going to work. You take that home and put it on a MacBook that has a different processor, it's not going to work. I hope that makes sense, yeah? Because every processor has a different instruction set, unless it's like the same like i7. You know what I'm saying, okay? So object code is fast to run because I don't have to go through it line by line and line. It's already compiled. It's already done all of that checking. So once it's developed that object code, that machine code, it will run. You do not need you do not need the code once it's compiled. Once it's compiled, you can just run that on any machine. That's what that's saying there. I've already said about the processor type, and the whole code is translated at once. Now, interpreters can be really useful to you because what that means, say, for example, you've written a piece of software on your computer, interpreters allow it to run through the environment more than anything. So if you've written a piece of software and you pass it to one of your classmates, if they have an interpreter, the interpreter will actually run it on that machine, okay? So it doesn't matter if it's got a different processor, because it's got the interpreter there, it will interpret that code and it will run it. It's like when you write a piece of software in class on PyScripter, does it still work on Python when you go onto Replit? Yes, it does, because it's interpreting it, all right? But interpreted code does it line by line rather than the whole thing at once. So you tend to end up with this issue where it crashes when it gets to a certain line, but it is more portable. think about it. If I've made my code, all right, and I use an interpreter, when I go home, I can still test it out there. All right. Used for interpreting source code, always needs the code at runtime. So it needs the full code at runtime. You can't just say, oh, I've written this piece of software and give them the object code and expect it to run on another machine. You need the code before you can actually physically run it. Yes.
Could you talk about the client being able to see the source code?
In interpreters, the client can see the source code.
Yeah.
With a compiler, once it's compiled, they don't necessarily see that anymore. It's not really a point I would go for. I'd talk more about once the code has been compiled, if you're talking about the compiler, that you don't need it anymore. All right. Yes.
You also say at the point one of them interpreter needs more dependencies to be installed.
Explain what you mean by that.
Like extra stuff like importing libraries, virtual environment.
I wouldn't go about that. No. All right. These are what I've taken from exam questions as the mark scheme. I've literally just pasted them straight out. So if you can memorize these, you're onto a winner. Okay. Any questions on that? I'll stop recording that. I will put that up so you can watch it back. If you memorize that table, it's going to help you a bit, no end as well. All right.